Hello, I am George David from Group 21, and our group chose to do its project on the Detroit demolitions from 2014 till present. And the main reason of our project was to sort of see who has the best prices, where it has the best prices, when you can get the best prices, and or where you can get the best prices. So here we have the average prices versus type of building. We have the average prices versus contractors. So the reason why we did average price versus contractors is because it's like who gives the best deal. Then we have average price versus council district. And then we have average price versus neighborhood. And then we have latitude and longitude, just to sort of like a GPS, I guess you could call it. If you had a map, you could just point out where each one was at. I'm just going to hide this real quick. And so the main thing that this should do is it starts off and it gives us a while loop. And the reason why we have a while loop is so that this can keep going until you hit encode. It doesn't even work if you click X on it. You have to hit encode. So the first thing we're going to do is we're going to do average price for type of building. And the average price for type of building will give you a table, a 2x2 table, and a pie chart, which is right here. And that 2x2 table says if it's a commercial building or not. So if it's a commercial building, it'll say no. Or if it's a commercial building, it says yes. So right here, yes. And then if it's not, it'll say no. And then it gives us the average price. And then the pie chart is saying that if it is a commercial building, it's 78.7% of the average price. And if it's not, it's 21.3%. So now we're going to go to council district versus prices. And council district versus prices, again, gives us a table, a 7x2 table of each council district and its average price. And it also gives us a plot, and that's the council district, that's the x-axis, and the average price is the y-axis. And then it's going to ask us to choose a council district from 1 through 7. And let's just say I live in council district 4, I don't know, something. And it says ANS, which is the answer, is the average price, 3.3652 times 10 to the 7th. And then, actually, I skipped over council district. I skipped over price versus contractors, so I'm going to go back to prices versus contractors. And once I go back to prices versus contractors, the reason why we did this one was because we just wanted to see who had, I guess you could say, the best price for the demolition. So it's going to pop up. Here it is. It's going to give us a 32x2 table of each contractor and its average price next to it. And then it's going to also give us a bar graph that's loading right now. I see it stopped running for some odd reason. I'm not sure why it canceled out of the bar graph. Oh, here's the bar graph. So the bar graph is it's the 32 contractors and then its average prices. And then it's going to ask us to type min or max for the maximum average or minimum average. So who had the most out of all of them? Let's just say we type in max. And it says the contract with the maximum average price is door and associates. And the average price is whatever that price is. So then we're going to go to neighborhood versus prices. Click neighborhood versus prices. It's going to ask us whether we want to see a bar graph or a table. So let's just say we want to see a table. We click table. It's going to give us a table, and it's a 172x2 table of the neighborhood and its average price right next to it. So there's that. And then let's just click it again, and then go to bar graph. If we go to bar graph, it gives us 172 things on the x-axis, and then it gives us 172 average prices. So let's go to latitude versus longitude, and again, we just sort of said that this is kind of like a GPS. If you had a map, you could just point out where each demolition happened. And this actually, for some odd reason, my computer doesn't like the curve fitting toolbox or curve fitting. It works on everybody else's computer in my group, but it just doesn't work on mine for some reason. So now we're gonna go in depth to all of the functions, and all of the functions have I say that it's a main function, and then I give it a graphing function, or we give it a graphing function. So we'll just go to here. So again, it's going to be a graphing function, or it's going to be its main function, its graphing function. And what I mean by its main function is its outputs are the inputs of the graphing function. So in the very first function, we'll have average commercial buildings. And the first thing we do is we give it inputs, prices in commercial buildings, and the price in commercial buildings comes from the data set. So we say that, where's the main script? So for the main script, the inputs is Detroit demolitions. We take price to end till the rest. And then string, we give it the string Detroit demolitions commercial buildings because it is a string. It's yes or no. And that's the input of the average commercial buildings. And then we take the average, then we take that, whatever comes out of there. So it's average in A. And then we take that and then we put it into average commercial buildings graph. So that is that. That's what we do for almost everything. If it had a string, we just put string in front of it. And if it didn't have a string, so like for council district, we just end up leaving it alone and just saying Detroit demolitions 2 till end. And the reason why we choose 2 till end is because if we choose it, just all of it, it's going to take the very first thing, which it's nothing. It's just saying whether it's a commercial building or not, which is not what we want. So time to explain the inner function of the code. The main functions, the first thing they do is they set a unique variable, commercial buildings. We say that however many times each one is chosen, doesn't matter. It's just yes or no in this case, because in commercial buildings, it's just yes or no. And then we take average P, which is actually should be the sum of P, technically, and then CB, which is the is just a storing variable. The reason why we set that equal to 0. And then we have a nested for loop here. The nested for loop says that for the length of A, so for the length of the unique variable, so just yes or no, and then it goes to the next one. For the length of commercial buildings, all the commercial buildings in the data set, we're going to string compare it. And what we say when we string compare is that if yes equals yes, technically, we are going, if yes, the unique character equals yes in the commercial buildings data set, we're going to take the price of that yes, and then we're going to add it, continuously add it, so the sum of it. And we're going to keep doing that, And CBAA, right here, this is the counting variable. So each time that yes is chosen, we add 1. And we keep doing that, and And then in the end, we take all of that, and then we divide it by however many times that it was chosen. So however many times, let's say like yes was chosen 150 times. Then a lot more because our data set has around like 10,000. But it's going to take that, and it's going to divide it by however much it had, however many times it was chosen by the complete price, the sum of its price. And then we go to its graphing function, which is sort of where the diversity in our functions come in. We take the inputs of this one are the outputs of this function. So here, the outputs of this function, average and A. And then from here we make a table and we make a pie graph. And that's all there is for that graphing function. Next one is the average contractor. Again, and this is very rinse and repeat. It's the exact same thing as the average commercial buildings. It's going to take a unique contractors. We set that equal to contractor. And then again, it's just going to go for the length of contractor, which is the unique. And then for the length of contractors in the data set, it will string compare every single time that contractor is chosen, add that price in, and then count that. Count that once, and then take the average price. And then we go to the graph for average contractor right here. The graph for average contractor. What we told it to do is we make a table in the first place, and then we make a bar graph, a nice little bar graph. We give it 33 x ticks, so 33 times, and then I set an x tick angle on there because it makes it easier to read for the contractors. And then for the table, we give it names for the top. So here I'll just choose price versus contractors real quick, and I'll show what I'm talking about here. The reason why I do t.properties.variable names. So the variables are now going to have names, contractor, and prices. And once it comes up, I should just type it in. Okay, once it comes up here, wherever it is. Once it comes up here, the reason why I do t.properties.variable names is so this right here, contractor and prices, can be on the top, so it doesn't leave you confused as to what's what. And then we ask you to input something. We ask you to type max or min for the maximum average or minimum average to see who had the best deal. And here I actually use two different ways to index the table. So I say take the max of column 2, and whatever that max is, set it equal to its name, which is Dorn Associates, and we just fprintf whatever that is. And then min, if it's the minimum average, well, I actually take the minimum of average. So I call to it two different ways into our table. Into the table that we made, and the name that we had here was average, and then it tells you what the minimum is, and then else it'll tell you if you type in anything else, it should say nothing. It should say nothing to show here. Try again, and then council district versus price. Again, rinse and repeat. But this time we actually do the unique variable equals council this time because it's not a string. We have to use equal. It's a number, and each time the number equals the number, added the price. And then the graph for CDVP is we make a table out of it, and again we give it the name CD and prices. CD is council district, and then we make a plot of it. So we put X as the which is the unique. Well, not unique yet. Yeah, it is the unique. It's 1, 2, 3, 4, 5, 6, 7, and then we take the average prices of it, and then we ask choose a council district, and from there. Whichever one you choose, it should give you the price. So we go into the table that we actually just made, and then it gives you that average price. So if we say choose, like let's say Council District 2, it'll go in to our table that we made, and then it'll say row 2, column 2, and then it'll bring it, and then it'll tell you what the price is. And then that's the graph for CDVP, Council District versus price. And then we'll go to NVP, which is neighborhood versus price. Neighborhood versus price, again, rinse and repeat. String compare, same thing, take the average prices, and then we go to graph for NVP. And this is where we ask you, would you like to make a bar graph or a table? And if you choose bar graph, here is the code to make a bar graph, right here. And then if you choose table, it makes a table. And then we have longitude versus latitude. So the longitude versus latitude, it just takes the scatter plot of our inputs, which is W and Z, and then gives it a title, gives it a label, and then asks for the curve fitting tool, and then just curve fits. And then we have imported data.m, which is actually what MATLAB gave us because we imported our data through the import data button. So this code really taught us how to use MATLAB. It uses all knowledge of MATLAB that we learned in this class because it uses everything. It uses while loops, it uses for loops, if statements, switch cases, menus, nested loops. It uses every single thing that we've learned in this class, and it asks us to do more, and it asks us to make functions of this function. It asks us to take the inputs of this function and make it into the outputs of this function. Everything that we've learned in class so far has used what this project has asked us to do, and that is why this code works for us very well. It taught us very well. Thank you, and that is it.